Okay, so looking at the computer printout or the output of our model, this is what it looks like in R. There's different software programs. You can do this in Excel or Python and R. Anyways, this is in R. And so how it's showing LM, that means linear model, formula Y tilde X, so Y versus X. These are the 5 residuals because we had 5 customers. Notice 2 of them, the first one and the last one, are negative. Actually, the fourth one too. So those 3 are negative, and that is consistent with our residual plot. The other residual 2 and 3 were positive. And then we have our coefficients. So our intercept coefficient, we calculated 75.2, and we calculated our X in our case was the time spent on the support chat feature, and we had 0.519. Beside that, we have the standard error for the slope X estimate, and that would be 0.06544. Here is our t-value. We got 7.93. The computer's going to have a little more precision. They went one more decimal place. And here is the exact p-value. It was 0.004175. Because we used the table, the t-table, we got a p-value. We knew it had to be less than 0.001, and in fact it is. We can see the exact value is 0.004. So this is a way to look at this. These stars mean that it's statistically significant in predicting the Y value. So residual standard error, that's the SSR residuals. We calculated that as being 4.38 on 3 degrees of freedom because we divided by 3 under the radical. They call it here multiple R squared, but it's our R squared, our coefficient of determination, 0.9545, so that was the same as what we got. And finally, we have an F statistic. And this F statistic is if we do test the overall model using ANOVA. So in the next video, the next few slides, I'm going to show you how we can do that and obtain that F statistic on 1 and 3 degrees of freedom, and then looking at the p-value and what does it mean.